Hello, everybody. Hopefully you can see that properly. Okay, so this is an update on OCFL, which is the storage layer that sits underneath Fedora or can sit underneath Fedora. Um, Currently implements version 1.x, and we are now working towards version 2. So this is just an update of where we are. Listed on that slide are the current editors of the standard. I'm Neil Jefferies from University of Oxford. I've been involved with Fedora for a ridiculously long amount of time, since the days of Sandy and Thorny, so probably 17 years or so plus counting. But latterly, I've been stepping back from Fedora per se and working on OCFL with the other guys. So when I talk about versions, for something that's involved with digital preservation, really versions have to change in a very careful way because we're talking about long-term and ideally permanent storage. OCFL has to try and version itself in a way that does not break earlier versions in specific ways, so that stuff has been written into OCFL compliant repositories remains compliant without an update. So there's a little bit of discussion. There's some stuff written into the spec already in terms of conformance of prior versions. And one of the things we're thinking about in version 2 is actually whether we strengthen that. And I'm going to talk a little bit about our deliberations later in this presentation. So the process so far, the thing about a preservation standard is it should move slowly and thoughtfully. So we're not rushing through this process. We started the version 2 process in last year in 2023. Um, and the first part of that was really holding a bunch of listening sessions with the community, holding a birds of feather meeting at last IPRES in 2023. Um, and then at the end of that IPRES session, we collated all the results of those, looked at those particular use cases, tidied those up, put those in coherent form, and actually put those out to the community in the early part of this year and asked the community to really vote in favor, against, or hold neutral opinion about whether these use cases should be included in version 2. At the end of that process, in March, we agreed the scope of V2 by marking the use cases and seeing what people have voted for. However, everything is online in GitHub, presentations also in the shared area for a showcase. So we're always looking for more information that we can feed into the process. So we've decided on the use cases that we are going to look at. So these are now listed on this slide, and as a result of the voting process, a certain number of the use cases that originally listed have been dropped off. And I'll just run through those quickly. There was the idea that OCFL might be perhaps going to become a formal standard, like ISO or something like that. I have been recently involved with the ISO standardization process, and there wasn't that strong a desire for it. Um, and certainly people didn't vote for it very highly. So that could happen in the future, given appropriate support and drivers, but right now it's not the main focus. So that's been dropped off. Some people had some issues with large inventory sizes, but most of the proposed strategies for doing those really only shrunk inventories by maybe 50%, maybe a little bit more than that, which really only marginally deferred the issue of large inventory problems. Um, and generally, there are ways around it. We're now looking at the ability to collapse object versions and do other things that may solve that problem partially. And it's perfectly possible to use indexing and caching techniques to get around that as a performance inhibitor. There was some discussion about distributed objects and components, and the general consensus, not just of the editors, but of the people who responded, was that that's outside the scope of OCFL. It's focused on an individual file system. Similarly, the support for external identifiers in the place of digests and other things like that were also considered out of scope. And if somebody was really interested in doing that, we proposed that maybe they might want to write an extension to do that. But it was really out of scope of the core specification. Um, And similarly, in terms of stepping outside of the file system, um, the idea it was it became fairly evident that the idea of managing multiple storage routes or peer storage routes within OCFL was again outside the scope of the specification. Um, there were relatively few use cases to see how that works, and actually the original institution that showed an interest in that functionality decided to do something else anyway, so that use case no longer existed. So what that comes down to is that we're going to focus on the 6 use cases that did pass muster and get enough votes. Um, and what this means is we're now going to analyze these use cases in detail. They are in scope for consideration as part of version 2, and we will try to work out how those can be supported within OCFL. It is still remotely possible that when these are looked at in very great detail, we decide for some reason it may actually be impossible to implement cleanly, but that's the basis on which we are going forward. In all cases, we welcome more comments from the community about these use cases. I'm now going to run through these in detail. I will say iPres 2 weeks ago, all of the editors got together at that conference, and anytime we weren't actually at the conference, we were actually working on all of these particular use cases. So all of them actually have been updated in GitHub with our initial thoughts on how they might be implemented within OCFL. And all of them we did feel that we actually came up with at least a reasonable idea of the way forward. We're looking for feedback on those ideas before we actually start codifying those in the specification. So first, and I think most popular use case was the ability to package up version directories into a zip file or a tar file or something like that. So the idea is to get around the problem of proliferation of small files that some archives have. Um, but also equally use the use of zip to actually handle very, very large files through split packages. Um, we need to not be too specific on the packaging formats we support. Um, and we should support objects with mixed versions, i.e. some versions may be packaged, older versions possibly. But for efficiency, we may prefer to keep newer versions or the versions that constitute the most recent version unpacked for performance and access regions. Um, the idea we came up with was to actually add a new file in parallel to the inventory, a package manifest of some sort, the presence of which indicates that at least some versions of that particular object are packaged. Um, and we think we're going to require that unpacking a package would result in exactly the same set of files as you would see in an unpackaged version. And that potentially means that you can choose to package up and unpackage a version without fundamentally changing the inventory. So the inventory represents the entirety of the object in its unpackaged form and remains working exactly the same way it did before. Support for physical file level deletion. There's been a lot of requests for this because there are legitimate curatorial and legal reasons. In version 1.x, you'd have to basically delete and rewrite a complete object to expunge that particular file. What it will do, if we support deletion, is it will break the immutability assumption, which means we're probably going to need to have some sort of flag, possibly at the storage root level, to indicate that there is the possibility of mutable content in the OCFL structure, and it will break version 1 compatibility. And the approach we're likely to use for that is to include some sort of tombstone mechanism in the inventory. Object forking comes from Zenodo, who the underlying platform Zenodo is something called Invenio RDM. And it supports version forking. They have some very large data sets, and sometimes that data set may actually split in two and then have two differently evolving versions, and they don't want to have to store two complete versions of that very large history. And after some initial discussion, we're looking at a mechanism that allows both inheritance between objects, but at the same time, that functionality actually provides deduplication between objects. So the mechanism could be used for both of those use cases. It's quite complicated. It means that an object need not be completely self-contained, which means we need to think about how things are validated very carefully. Um, and because of the other features, things like object deletion, or file deletion within objects, we have to think very carefully how objects with shared history actually interact with each other when operations like this are carried out. Um, so this one looks like it's quite tricky, but it would enable platforms like Zenodo, Invenio RDM platforms to actually use OCFL as a storage layer and not just as an import-export format. Application profiles. Um, so besides just looking at an object as a general notion, can we actually, within OCFL, store some more details about the structure of an object that are application specific, that would help in terms of documentation and portability? And really, there are two ideas around that. A very simple implementation might be just a place to put documentation about your object structures. But more aspirationally, and some work has been done in some areas around this, is it possible to have a machine actionable configuration, something that actually a machine can digest and help to validate objects in more detail than OCFL currently allows? Um, and the editor's thinking on this is that we're likely to be relying heavily on the extension mechanism from this rather than the core OCFL specification per se. But we can see an argument for producing a template extension for this material, this sort of use case. Flagging file loss corruption. This is really dealing with write once media, or even read write media with the idea of immutable storage in some sort of way. What happens when an object gets lost, when it gets corrupted, when it becomes partially readable? How do we flag that in the inventory when we know we're not going to rewrite the whole of storage to accommodate that? Um, and our thoughts on that is we can actually use a modified tombstone mechanism as we use for file deletion to indicate that sort of use case. And that's now been written up as well. So we may handle file loss corruption and active deletion using pretty much the same mechanism to just indicate this file is not there as originally envisaged in some way, and documenting that within the inventory. Finally, another thing that turns up, this is partly coming out of some of the mutable head work, but also looking back at OCFL in more detail as people come to curate things down the line. What happens if there are versions of an OCFL object that are not considered curatorially significant, especially in hindsight? Is there OCFL support for collapsing versions? And really, we can see two approaches to this. Do we want to actually retain information about the fact that versions are being collapsed? Or do we just want effectively a new version of the object, which omits those of the existence of those versions entirely? At the moment, if you want to erase all notion of the existence of those versions, probably the best way to do that is, as we do at the moment in version 1, is to rewrite the object with a revised version history. But if we want to keep some information about the existence of those versions, just remove the files, then we're going to break the idea of version immutability within OCFL. So again, we're going to have to flag that in some way. So there are two really different approaches to collapsing OCFL versions. And the consideration is, if we're just deleting files from a version, but keeping the information about the existence of those versions, then again, that's another application of tombstoning. So what we're looking to do is try to use the same mechanism to implement as many of these use cases as possible, so that the net effect is we are making as smaller changes to the OCFL specification as possible in order to accommodate these requirements. So getting to version 2. As I said, at IPRESS 2024, editors worked through all the in-scope use cases, came up with approaches we think will work. Those are now written up within the issues in GitHub, and people are starting to post feedback in there. And we're going to let those sit there for a little bit, so people can comment on those. And I'll be popping up in various places like here to tell people that this is there. Can they please do make their comments? It is still possible that we may hit roadblocks and that some of those may be either postponed or abandoned, but we're pretty sure we got away ahead with all of those. And we're still thinking about exactly what the timeline is going to be. The timeline for version 1 was quite slow and thoughtful, and we're thinking we're not going to try and hurry things any more than necessary for version 2 right now to ensure plenty of time for review, because the idea is this should be something people can use for a long time. And at the same time, we're also thinking when we do want to come to release the new version, we're going to be developing fixtures and error messages and tests for that. But we would also like some level of implementation for release as we did for version 1. Because there are a number of different features there, the question is what level of implementation do we require before we consider release? Do we require enough different implementations that all of those particular use cases are covered? Because not all implementations need to implement all of that functionality. Or are we looking for something comprehensive? And that's something we're thinking about at the moment. Once we've released 2, then we expect a period of stability, hopefully quite protracted, and we'll only do point releases really for minor changes and corrections that we don't expect to substantially change the specification or the validity of file systems, and that's what we did with version 1. So after the meeting at IPRES, we did have a little bit of thinking about compatibility, and came up with some more principles about how we're going to proceed. The first one, as I mentioned, is to try and make as few changes to the spec as possible to meet the requirements of the use cases and to stick to the use cases as written. Don't or try and avoid as much as possible scope creep in terms of adding functionality that, oh, that might be neat to just add this other feature. If it's not requested in the use case, it's not happening. Try and make the changes as simple as possible. Try and replicate design patterns rather than introduce new ones. So, for example, we consider that the package inventory should work very much the same way as a regular inventory. We need to make it easy to identify when version 2 features that would break version 1 validation have been used, so that validators can easily identify when they can expect version 1 compatibility to break. And as much as possible, we're going to change the spec in such a way that a version 1 object will be version 2 compatible with no changes. So rather than changing how existing parts of the inventory specification might work, we would add to the inventory specification so that there might be a new block or something like that. But the old parts of the inventory would continue to work exactly the same way as they did before. And that will mean we have to be quite careful when we're constructing the specification to do that, much more mindful of the effect of changing to a new version than you might be ordinarily. And that's really it is. There's a bunch of links here. The presentations are with you. We now have hex stickers, although they're all, Simeon's got them all. As far as I know, we handed them out at IPRES. We'll be dishing them out at other places as well. Do please comment if you have any thoughts on any of those issues, because that's now going to feed into the implementation. We're going to let things sit for a little while and then come back to those to collate the feedback that people have given us, and then sit down and start doing some spec writing. And that's it from me. Thank you very much.
Thanks, Neil.